All right, my AB kids, we're looking at section 3.2 on implicit differentiation. It's kind of a cool thing because there's like a set way to do this, and you may not remember what it means to be implicit versus explicit, but we're going to talk about that first today. So if you are an explicit equation, you look like this. You would be something like y equals x plus 16. And if you're implicit, it would look something like this. X squared plus y squared equals 16. There's a difference between the two. And you can see that for the first one, it's solved for a single variable. That equation is solved for a single variable. Where this guy over here, Mr. Implicit, he is not solved for a single variable. In order for us to do our calculus, to do our derivatives, it has to be solved for a single variable, or there has to be a different way that we approach it. And really that's the whole story to this. So if I look at this, if I take the derivative, d over dx is a form of asking you for a derivative. So d over dx, what's the derivative of x? Well, the derivative of x is 1. What's the derivative of x squared? Now, sometimes you might see it this way. Let me go back to this one for a second. If I say this is like the derivative with respect to x, so it's dx over dx, and that equals 1. This one, if I look at it in this respect, it's going to be 2x, but I took the derivative of x, dx over dx, so I get an answer of 2x. In this case, remember e's, we love e's, e to the 5x times 5, the derivative power, but I took the derivative of x, dx over dx, and so I end up with an answer that is e to the 5x times 5. Now how about if I change things up and I talk about y's, y variables? This guy here, if I do the same thinking, because my variable was x over here, this was dx over dx. Because my variable over here is y, it's dy over dx. Can't do more than that. This one would be 2 times y times dy over dx. This one would be e to the 5y times 5 times dy over dx. Do you see the difference in the variables there, how that works? So, here's our first example. Find dy over dx, the derivative, for y squared minus 5x cubed equals 3y. And so they talk to you in terms of steps to do this, which is kind of nice of them. First, you're going to take the derivative. But each time you take the derivative of a y, you have to say so. So you've got to include dy over dx. We actually, or you can use this notation, or what I'm going to use, the same thing is y prime, just because it's less writing. So I'm going to call it y prime. But again, you can use dy over dx, that's fine. All right, so let's do that. Here I am. Here's my equation. Every time I take the derivative, and I'm taking derivatives the same way I always would, if this were an x squared, this would be 2x. Since it's a y squared, it's 2y. So it should be 2y, but I have the derivative of a y term, so I have to say so. That's times my y prime, or dy over dx, if you want to put that too. Come to the next term, minus 5x cubed. That would be a 15, 3 comes down, 3 times 5 is 15. X to 1 less power, x squared. But I took the derivative of an x, so I don't have to say so. See how when I take the derivative of an x term, it just is 1, so that's okay. Equals. And then I have a 3y. So the derivative of 3y would be a 3, but I took the derivative of a y piece, so I have to say times a y prime, or dy over dx. Gather all the terms with dy over dx, y prime in our case, on the left, and everybody else goes to the right. So I have 2y times y prime. I'm going to bring the 3 over, the 3y prime, minus 3y prime equals, bring in the 15x squared to the other side. You see, your y primes are on the left, everybody else is on the right. Factor out y prime, dy over dx. So if I factor that out, it's going to be y prime, and then I'm going to have parentheses. And in parentheses, if I take the y prime away, I've got a 2y. Take the y prime away, I've got a minus 3. And on the right, I have a 15x squared. And then it says, okay, solve for y prime. So I'm going to have y prime equals my derivative equals 15x squared. These are attached by multiplication, so I'm going to undo the multiplication by dividing, and I put it over 2y minus 3. And that's it. That is implicit differentiation. So the only difference is you've got x's and y's, and by the way, they could throw z's in there, they could throw all sorts of crazy variables in there, and you're going to need to, each time you take the derivative of something other than x, you have to say so. So if you had a z in there, then you'd be doing a z prime in the midst of it, but that's Calc 3, and we don't need to worry about that quite yet. So for now, you're going to be taking derivatives, and anytime you take the derivative of something other than x, it's going to be a y. You're going to say y prime, or you're going to call it dy over dx, whichever you choose. And then get that dy over dx, y prime on the left, everybody else on the right, solve for y prime, and there you go. That's implicit. It's kind of nice because it's like it gives you a set of steps to be able to get there. So let's try a couple. This next one is kind of like the one we just did. Let's see. I have a y cubed. All right, so he's going to be a 3y squared, but I took the derivative of a y, minus 2x is 2, x to the fourth, 4x cubed, never liked x's so much, plus a 2, but I took a derivative of a y. Everybody with a y prime goes left, everybody else goes right. So I have a 3y squared, y prime, minus a 2y, just a 2, y prime, equals 4x cubed plus 2. I'm bringing this guy to the right, he's a plus 2. Now you might or might not like the colored pencils, but for me, in the start of this, it makes me happy to have the different colors so I can see who I'm trying to get by himself. If you don't enjoy colored pencils, it's okay. Y prime, factor it out. 3y squared minus 2 equals 4x cubed plus 2. So what ultimately does y prime equal? It equals 4x cubed plus 2 over 3y squared minus 2. And that's your final answer. Now, are they all quite that straightforward? And the answer is no. Here we're going to get some trig going on. We all love the trig. The sine of xy. Now this one's going to be interesting. By the way, you always know that you want to do this implicit stuff when you see x's and y's together, when it's not an explicit equation, when it's not y equals something, which is what we've seen so far. So when you have x's and y's intermingled, then you're going to have to use this implicit stuff. Now I'm looking at this, and I know that at some point I'm going to have to take the derivative of that angle, which is xy, and the derivative of that is going to be a product rule. So keep that in the back burner as you're trying to start this thing. So the derivative of sine is cosine. Okay. Cosine, you don't change the angle of xy. But then you have to multiply it by the derivative of what the angle is. That's where we're getting into this whole implicit stuff. So the first times the derivative of the second. Well, the derivative of y is 1, but you've taken the derivative of y piece. Plus the second times the derivative of the first, which is 1, equals the derivative of 10x, which is 10. Let's see if we can clean it up somewhat. I have the cosine of xy times x y prime plus 1 equals 10. Oh, mistake. Did you catch it? Y times 1. This is a y. All right, this is a little tricky. I'm trying to work towards getting this y prime by itself. Right, I've got to solve for that. I've only got one term this time that has it. So let's see if we can start taking things and moving them to the other side. So this term that's in xy, by the way, let me take away, this is all one piece. Let's see, xy, maybe I should keep it this way. Keep it in parentheses, right? Because these two are being added, but this guy's being multiplied. So if I keep it in parentheses, brackets, whatever, it looks like this. I'm trying to get towards this y prime. So I need to get rid of this cosine xy that's in front. So that's going to give me x y prime plus y. They're attached by multiplication, so to move it over, I've got to divide 10 over cosine of xy. All right, then I'm going to get the y. I'm trying to, again, dig towards solving for this y prime. So I'm going to subtract y. That's going to be my next move. Next move is x y prime equals 10 over the cosine of xy. And I brought this y over, minus y. Now it's interesting what they did next with this one, because what you're going to do next is divide by another x, right? You've got these two, you're trying to get this y prime by itself. But if I divide by another x, now I'm into complex fractions. So is there a way I can keep myself from thinking about this being a complex fraction? And the answer is yeah. Now go back to your trig identities. If I have 1 over cosine, that's the same thing as secant. So this first term could be written as 10 secant of xy and then minus y, which is going to make your life easier for your y prime. Y prime equals 10 secant of xy minus y over x. That's your final answer. And they only did that to avoid that whole complex fraction concept on that problem. All right, so let's see the next thing with implicit. This one says, all right, find the equation of all tangent lines for x squared plus y squared equals 4 when x is 1. This is a circle. X squared plus y squared is a circle. The 4 tells you what the radius is. The radius would be the square root of that. It's 2. So in this case, we've got it, and you can see the picture. We've got a circle whose center is at the origin and the radius is 2. And they say when x equals 1. So when x equals 1, we're talking about what's the tangent line here and what's the tangent line here. The tangent lines would look like this. I don't know if I can do this right, but you get the idea. Whoop, not bad. Okay. They're the two tangent lines that I want to know. Find the equation of the tangent lines when x is 1. So I have two different tangent lines, and you can see that one of them has a positive slope and one of them has a negative slope. And so my job is to figure out what that slope is. Well, slopes are derivatives. The question is, what's the derivative when x is 1? Let's figure out the derivative. M equals whatever my derivative is, y prime, which is, I'm going to figure this out. Let's go here. It's going to be x squared is 2x plus 2y times y prime equals, and here's a lot of kids get this wrong, interestingly enough. What's the derivative of 4? Right? Because that's the next piece I've got. This is x, this is 2x, this is 2y, okay? This is the derivative of 4, which is 0, right? I can't tell you how many kids will put a 4 down there and end up with it wrong. So there you go. I am going to continue and solve for my y prime. So I have a 2y y prime equals a negative 2x, right? I'm going to bring that to the other side. So y prime, my slope, equals negative 2x over 2y, or negative x over y. So I need to figure out what the coordinate is, because I know what x is, but I don't know what y is. By the way, if I'm trying to put a tangent line together, I need to have solid numbers. I can't just like leave it as an equation. So I need to know what this actually is in a number form of some sort, whether it be a fraction or whatever, but I can't just leave it as negative x over y. So I know that x is 1, so let's think about this. If x is 1, I'd have x squared, 1 squared, plus y squared equals 4. And so I'm going to take that and I'm going to solve it for y, so I can figure out what the coordinate is for this. I want to know what that coordinate is. I know this is 1 something, I know this is 1 something, but I don't know what that something is. All right, 1 squared is 1, bring it to the other side, that's going to be 4 minus 1, so I get y squared equals 3. So y equals plus or minus the square root of 3, and that's what's in here. This is a positive square root of 3, this is a negative square root of 3. So I'm going to go back to my, I've got two situations going on, what my slope's going to be. So I'm going to have, if x is 1, I've got to, let me put it this way. If I'm at the coordinate 1 square root of 3, then my m is going to be x, negative 1, over the square root of 3. So I have my point and I have my slope. I can put my tangent together. So if I'm at this location, then I am at y minus the square root of 3 equals negative 1 over the square root of 3 times x minus 1. So there's one of my answers. Sorry, the fire alarm's going off. If I'm at the other location, still positive 1, negative square root of 3, then my slope is going to be negative 1 over a negative square root of 3, or a positive 1 over the square root of 3. So here we go. Y, my tangent, is now going to be y minus a negative square root of 3, y plus the square root of 3 equals 1 over the square root of 3 times x minus 1. And so those are your equations for those tangent lines. Horizontal and vertical tangent lines exist. Horizontals are when the slope equals 0, and that's always going to result in y equals some number, which is always going to be a horizontal line, right? And if I'm a vertical, that's when the slope is undefined. Remember Mr. Slope Dude? All right, so it's going to be x equals some number, and you're talking about a vertical line where the slope's undefined. These come up a lot on the AP exam. So find all the and we've seen it. I think we've seen it in a few problems since we started here. Number 4, find all the horizontal tangent lines for this guy. Well, we know that that's going to be horizontal is when the slope is 0. What's the slope? The slope you got to figure out using derivatives. So here it is. 3x squared gives you a 6x. 2y squared gives you a 4y. Oop! You took the derivative of a y. Y prime equals 16. 16 is 0. Find the slope. Solve for it. Move the 6x to the other side. I've got a 4y, y prime, and I've got it equaling to a negative 6x when I bring that to the other side. So y prime is equal to negative 6x over 4y. 2 goes into them, negative 3x over 2y. Well, when does that equal 0? So let's think fraction-wise. Let's go back to what the rule that they talked about. If I'm going to go to the margin. Can you see me? No. Let me fix me so you can see me. So this is a little girl from, can you see her there? Her name's Sabia, and she's from Bangladesh. She's a kid that we kind of semi-adopted, if you know what I mean. Anyway, food for the hungry. So if you see her little face on my calendar, she's there so I can remember to pray for her. All right, so here we go. I have horizontal I was talking about. If I'm thinking of a fraction and I've got some fraction, I'm going to say a numerator over a denominator. Oh, that's rocket science, right? If I'm a horizontal line and my slope equals 0, and you're going to see that come into place for this guy. If my slope equals 0, and I'm really at this location right here, it's as if this 0 is over 1 and I'm going to cross multiply, and look and see what happens. It ends up that 2y times 0 is 0, but negative 3x times 1 is negative 3x. So I should do it this way since I'm trying to do it generically. It turns out to be that I have negative 3x equals 0. What happened? What part ends up equaling 0? I end up with the numerator equals 0. The denominator gets just disappeared. It goes away. So kind of cool. So the numerator, when it's a horizontal and the slope equals 0, it's just take your numerator and set it equal to 0, and that's going to be it. Let's finish this out. So divide by negative 3, I get x equals 0 over negative 3, or 0. Hold on a minute. We got issues.
Can you pause that?
No.
Okay.
My husband just came in and it got me all off kilter. But I need to go back. I agree with this x equals 0. All right, so nonetheless, all right, I've got a slope of 0. Never mind. We're good on where we're at here. Let me go to, we're going to do vertical. We're going to add to our margin in a second. So it says find all the horizontal tangent lines. What did I just find right here? I found that when x equals 0, that's going to be where I have a horizontal tangent line. But that's not the answer to the question. The question is, where is it? Find all the horizontal tangents. I'm just saying that when x equals 0, that's when I'm going to have a horizontal tangent line. So let's figure out where that is. Well, go back to your equation. If x equals 0, I'm going to come over here where I've got some space. 3 times 0 squared plus 2y squared equals 16. Well, this zeroes out, right? 0 squared times 3 is 0. 2y squared equals 16, or y squared equals 8, square rooty, and I get y equals plus or minus the square root of 8. That's the final answer. And it should line up, because remember back up here, we said horizontal tangent lines are when y equals a number. Your answer should be y equals a number, and that's what we've got. Y equals plus or minus the square root of 8. Could you call this 2 square roots of 2? Yes, it would mean the same thing. All right, vertical tangent lines. If I am vertical, then I know my slope is undefined. Let's check this out. Same question, actually. So I take that same 6x plus 4y, y prime, equals 0, derivative of 16. So I get the same deal. I'm going to say, I don't have to redo the work, right? I know that y prime equals negative 3x over 2y. Well, think about when a fraction is undefined. A fraction is undefined when the denominator equals 0. So now I need to know when the denominator equals 0. So you see, for horizontal tangent lines, the numerator equals 0. For vertical, the denominator equals 0. So they're a little bit different. You need to remember that. So if I set my denominator equal to 0, then I've got, I know that 2y has to equal 0. So y equals 0. When y equals 0, that's when I'm going to have, so if I keep the same lingo I had over here, when y equals 0, I have a vertical tangent line. All right, let's check it out. 3x squared plus 2 times 0 squared equals 16. 3x squared equals 16. X squared equals 16 over 3. So x equals plus or minus the square root of 16 over 3. I guess I really could call that plus or minus 4 over the square root of 3. Remember, Mr. AP does not mind you having square roots in the denominator. And now you have figured this out, because it should be x equals a number for a vertical tangent line, and here you go. You got it. All right, we're going to try a few practice problems and call it a day. First one I picked was number 3. Number 3 says, again, I got signs of x's and y's. I know I need to go implicitly on him. So if I do that, the derivative of sine is cosine, same angle. Derivative of what's inside. Well, what's inside, no equals yet. What's inside, the derivative of x is 1, and the derivative of y is 1, but it's a y prime. Derivative of 2x is 2. We're going to dig to get this y prime by itself. I'm going to divide by cosine of x plus y. So I get 1 plus y prime equals 2 over the cosine of x plus y. And then I need to subtract the 1. So y prime equals 2 over the cosine of x plus y minus 1. Now, this one you could change it. Remember in that last problem, one of those last ones that we did, because you ended up with a complex fraction, we ended up changing this to secant. You still could do that, but this is a perfectly valid answer. You're not in complex fraction territory, so you really could call this 2 secant of x plus y, y minus 1, and that would be an equivalent answer. Again, if this were a multiple choice question, you just would have to choose which multiple choice format they have it in. But that's it for that guy. Let's see what else we've got. Number 5, we'll do a little bit of Ian. number 5. So I've got a 5x squared. That's going to be a 10x minus e's. Give me e to the 4y squared times the derivative of the power 8y times a y prime equals the derivative of a negative 6, which is 0. Now get to the y prime. 10x has to go to the other side, so I'm going to have a negative e to the 4y squared times 8y y prime equals 10x to the other side is a negative 10x. Now all of this is all one piece, so really y prime is going to equal the divided by of this. So negative 10x, I have an 8y that's also negative, e to the 4y squared. Can I make that prettier? A little bit. Negative 10, negative 8 gives me 5 over 4. I know I have a fraction. So my fraction has a 5 on top, a 4 on the bottom, an x on the top, and then I have a y, e to the 4y squared. And that's the best I can do for him. So one with a little bit of e. 9 was my next one. It's got ln's and it's got trig in it. Remember that this guy here, this cosine squared x, is the same thing as cosine of x squared. So let's try this one. Derivative of ln of y squared is going to be 1 over y squared times the derivative of y squared, which is 2y, times y prime, plus, now I'm ready for this guy, 2, power comes down, cosine of x, 1 less power, times the derivative of cosine of x, negative sine of x, equals, oh gosh, I'm running out of space here. Derivative of 1 is 0, derivative of negative y is negative 1, so it's going to be a negative 1 y prime. Let's see if we can make this any better. All right, I'm going to clean it up before I start moving things around. This would be 2y over y squared. So I've got a 2 on top. The y over y squared gives me a y on the bottom times y prime. This one, this is a positive. This is the negative. It's not a subtraction sign. So positive times negative makes this negative 2. It's a cosine of x and a sine of x, whatever order you want, equals a negative and then a y prime. Everybody with y prime has to go left. Everybody else goes on the other side. So I'm keeping this 2 over y prime. I'm bringing the other one that's negative. It's going to turn positive over here. It's going to be plus a y prime. Equals. This guy's coming to the right. He's now going to become positive. 2 cosine of x, sine of x. Factor out the y prime. Gives me a 2 over y plus, don't forget the placeholder of 1, equals 2 cosine of x, sine of x. This one gets pretty ugly, but that's where we're going to leave it. He's going to be happy being ugly. Y prime equals 2 cosine of x, sine of x over 2 over y plus 1. And that's the best you got for that lovely problem. Did you catch all that there? I was babbling and not paying attention that I was off your screen. So I'll give you a second to see that. We're going to do 13. 13 is next. A couple more to go. 13 is interesting because 13 ends up being a product rule. And it ends up being a product rule because if you look at this guy, you have an x and you have an e to the 3y. So you've got to product rule that with an x and an e to the 3y. There's two pieces. which makes this a little bit more challenging. All right, so let's go at it. It's actually the ln of x is your first piece. So if I do the product rule on it, it's going to be the first ln of x times the derivative of the second, e to the 3y times 3 times, I did a y prime. First times the derivative of the second plus the second, e to the 3y times the derivative of the first, 1 over x. ln of x is 1 over x equals 2y squared is 4y, y prime. Everybody with a y prime goes left, everybody else goes right. I have, if I make this any better, 3 ln of x e to the 3y, y prime, minus 4y, y prime, equals e to the 3y over x. And that should be negative, right? Negative on that guy. All right, y prime, take it out, factor it out. 3 ln of x e to the 3y minus 4y equals this same fraction, negative e to the 3y over x. So y prime equals a fraction with a negative e to the 3y on top. I have an x in the denominator along with what I'm going to divide by, 3 ln of x e to the 3y minus a 4y. And that's it. All right, directions change for a couple of these. I just wanted to show you that one because it is a product rule in the midst. Like for number 12, you're going to end up having to quotient rule that guy, so just be ready. They're coming along with different things in there. All right, here comes the next guy that I want to look at. Find the slope, number 14, of the tangent line at a given point. Show your work. All right, well, here we go. 14. Find the slope. Well, slope is the derivative. Let's go derivativing. So if I do a derivative of 2, I get 0. Derivative of 3x to the 4th is 12x cubed. X, y to the 4th. Oh, lordy be, I got a product rule again. First times the derivative of the second, 4y cubed y prime, plus the second, y to the 4th, times the derivative of the first. Derivative of x is a 1. All right, well, this one's kind of interesting because they gave you an actual point. You know what x and y are, so you really can just plug that in at this place. So here you go. They want to know what's the slope. Well, the slope's going to be what you're looking for is this y prime. You'll see it turns out that you're going to be able to solve for that pretty easily. X is negative 1. 12 times negative 1 cubed plus negative 1 times 4 times y cubed, 1 cubed, y prime. Don't know what that is, right? That's my unknown. Plus y to the 4th, 1 to the 4th, times 1. Just plugging in the x's and y's they gave me. Negative 1 cubed is negative 1 times 12 is negative 12. Plus 1 cubed is 1 times 4 is 4 times a negative 1 is negative 4. So this will be, instead of a positive, it's going to be a negative 4 y prime. And then the last one, 1 to the 4th is 1 times 1 is plus 1. And you see how now you're going to be pretty easy to solve this thing for your y prime. So you've got 0 equals negative 12 plus 1 is negative 11 minus 4y prime. Take the 11 to the other side. That gives you positive 11 equals negative 4 y prime. And so y prime equals 11 over negative 4. And you've just figured out what that slope would be. Number 17 is my next one. 17 is a good old trig function guy. And again, I have a product rule in the midst. Sorry this has taken longer than I would have hoped, but you know, giving you the good signs here. I have a product, oh gosh, I got a product rule on either end. Holy moly. Okay, so I am going to first times derivative of the second. I'm actually going to come over here and start it. So the first is x times the derivative of the second. Well, the derivative of sine is cosine, same angle, times the derivative of the angle, but it has a y, so it's a y prime, plus the second sine of 2y times the derivative of the first, which is an x, which is 1, equals, go to the right, first y times the derivative of cosine of 2x, which would be a negative sine of 2x times 2, plus cosine of 2x times the derivative of y, which is a y prime. Boy, good thing I gave myself enough room. Now if I employ the same concept as the last time, I'm just going to plug in x is pi over 4 and y is pi over 2, and I'm going to see if I can solve for the y primes. See where that takes me. X is pi over 4. Cosine of 2 times y, pi over 2, times 2. I'll put the times 2 out in front. Y prime. Plus the sine of 2 times pi over 2, my y, times 1, equals my y, which is pi over 2. It's going to be negative, so I can take care of this negative sign. Sine of 2 times pi over 4 times 2, plus the cosine of 2 times pi over 4, and then y prime. That's crazy! Well, 2 times pi over 4 is pi over 2. This is the cosine of 2, the 2's cancel. So I've got the cosine of pi, and if I'm on my unit circle and I think about pi, actually I'll put it up here. Think about pi. Pi is when x is negative 1 and y is 0. Cosine is the x value, so this would be a negative 1. And then I've got a y prime. Plus. The 2's cancel out. The sine of pi is the y value, so that's 0. That takes care of that guy. Equals negative pi over 2. Sine of 2 times 2 is 4. They cancel with the 4 on the bottom. The sine of pi is 0. So this would be times 0. Plus. This would be pi over 2, interestingly enough. Pi over 2, if I'm at pi over 2 on my unit circle, I'm up at the top. I'm at 0, 1. And so cosine is the x value, that's 0. 0, y prime. So let's see what we got. We got a whole lot of 0 on the right. Huh. Hold on. Pi over 2 cosine of pi over 2 times 2. There's a problem in the midst. Let's see, did you catch it already and I'm just not catching it? cosine of 2y, pi over 2, 2 times pi over 2 is pi, 2 pi, 2 times, oh, no, this is okay. Sorry, looking for the mistake. Pi over 2 sine. I think it's here. Here's my issue. Let's try this. This one, I took this 2 and multiplied it as if it were part of the angle. Let me change this and put it out here, out in front like we did with this guy. So times 2. That's this 2 that I'm talking about in the midst. So that's going to change this up to be, if I multiply that by 2, that's going to make this a negative pi, not a pi over 2. Sorry about that. Let's see if we can fix this right-hand side here. So 2 times pi over 2 is a pi. It was a negative pi. There it is. This is the sine of pi over 2. The sine of pi over 2 would be the y value, which is 1. That's better. That's 1 from my coordinate here. And then I have plus, this is pi over 2. The cosine of pi over 2 is 0, and so it is plus a 0 y prime. Okay. So I end up with a negative pi over 2 y prime on the left, and on the right I have a negative pi. So y prime is equal to negative pi divided by negative pi over 2. Now I went horizontal on you because I'm going to keep change flip, otherwise I'd have a complex fraction. So negative pi times 2 over negative pi. I'm saying the right thing and writing the wrong thing. The negatives cancel, the pi's cancel, and I get an answer of 2. Now what does that represent? That, my friends, is your slope. And so the question wanted the tangent, and the tangent is, you've got your coordinate right here. So you're just going to put it together, y minus pi over 2 equals 2, my slope, times x minus pi over 4. Shoo, that was a lot of doing. All right, next one's the last one. Last one. 18 is what I chose. 18, find the equation of the horizontal and vertical lines. Oh, horizontal, vertical. Let's go for figuring out what the derivative is first, because remember from our notes in the margin, when the numerator equals 0, where am I? Find my right sheet here. If it's horizontal, I set the numerator equal to 0. If it's vertical, I set the denominator equal to 0. But I just need to get there to that derivative first. So here I go. X squared is 2x. Derivative of x is 1. The derivative of 2y squared is 4y, y prime, equals 0. Derivative of 8 is 0. I keep my 4y, y prime on the left. Everybody else goes right. Minus 2x minus 1. And so when I put this together, I have this fraction, and my fraction is y prime equals negative 2x minus 1 over 4y. Again, horizontal, I set the numerator equal to 0. Horizontal, negative 2x minus 1 equals 0. Negative 2x equals 1. X equals a negative 1/2. Well, that's not the answer to the question. It's go back and plug that into the actual function that you started out with. So I'm going to go into box number 19. I'll have 2. This gets kind of complicated in the midst, but here's what it's going to be. It's going to be my x squared negative 1/2 squared plus a negative 1/2 plus a 2y squared equals 8. And what you need to do is go into your calculator and solve that out. So when you solve it out, it's going to be positive 1/4 minus 1/2 plus 2y squared equals 8. And you can keep going with solidifying this thing, solving it down. But it turns out that y equals, when you're all said and done, y equals plus or minus 2.031. You can use the solve feature on your calculator. That'll get you there too. For your vertical, that's going to happen when your denominator equals 0. 4y equals 0 when y equals 0. So you're going to take that 0 and you're going to plug that in again into your equation. And that's going to give you x squared plus x plus 2 times 0 squared equals 8. Or in other words, x squared plus x equals 8. You got to put everybody on the same side, quadratic formula, use your happy-dappy calculator, and that's going to give you two values. And your values for this guy are x equals negative 3.372 and x equals positive 2.372. And so there are your answers. Horizontals plus or minus 2.031. And your verticals are when x, I should say y equals, x equals negative 3.372 and x equals 2.372. Okay? Can you see me? Now you can. All right, that takes care of section 3.2. There's a whole lot of stuff going on in that one. But I will see you in class and take all your questions. You can email me if you need to, and I will see you then. Have a good day. Bye.